Hello everyone, good evening. Myself Yamini Agrawal from the Department of MCA on behalf of VISIT welcomes you all to today's session of We Reach 2020, an Alumni Engagement Initiative. Now I would request Professor Mona Deshmukh to put some light on today's session.
Hello everyone, welcome. Thank you for joining with us for today's session of We Reach 2020. We Reach 2020 is a VISIT Alumni Engagement Initiative which is brought to us by the VISIT's Internal Quality Assurance Cell and Institutions Innovation Council. We Reach is an online teaching learning platform where our VISIT alumni share their vast knowledge and experience with our students for their professional development. Today, we are presenting the database on cloud presented by Gourav Salanke. Now, I turn the time over to Gourav.
Hello friends, it's see you among this COVID situation. It's always good to interact with people, especially fellow college students. It's been a while. I have passed out from VISIT. I was studying in MCA. I am from 2009 batch, and it was absolutely crazy journey throughout those 3 years. And when I'm saying crazy, I mean it was amazing. So right from a lot of intercollegiate events to lectures, then lab sessions. It was amazing. I mean, intercollegiate festivals or intra-collegiate festivals, sports days, etc. Everything was so amazing. And of course, all the classmates. I have made so many good friends there. So I cherish my journey over there. You being Visitians and coming out of the college, you're going to get into a very good corporate world, hopefully, or you will start some of you might start your own ventures, those who are aspiring to be entrepreneurs. So I thought in today's session, we can have a close look at databases, which are going to be very important. Any application you build, most of them, of course. So you would have heard a lot of buzz around cloud computing these days. So I thought for today's topic, I'll choose something to do with databases on cloud. So let's begin the journey. Let's see what all we can cover today. So just to give you a brief idea, these are the topics I'm thinking of taking over today. So we'll briefly see what is cloud. Then we'll see basic things about hosting applications in the cloud, so that before we get into databases, at least we should have a fair idea about what all options we have to host the base apps on the cloud. Then we'll see what makes databases so important. I mean, I did not choose apps as my topic. More than that, I thought databases is a very good topic for you guys to know about. So we'll see why is that. We'll see types of databases, a broad overview about it. Then we'll see why host databases in the cloud. Then we'll see how to load balance your databases. And just a disclaimer sort of thing, I'll be mainly talking from web development point of view, but the world in cloud computing is not limited to that. And for demonstrating purpose, I'll be using Amazon AWS. But again, that's just one of the service providers for cloud. There are various other service providers and similar options with them, whatever we are going to cover. Let's look at some prerequisites. I assume that you know database fundamentals, database administration, and application development. Well, I've said well, sort of, because some of it I'll be briefing I mean, as far as I can brief in a short period of time, so that even for those who are uninitiated in this domain, they will have fair idea about what we're talking about instead of just looking at my face with a blank face of yours. So I think, yeah, let's dive in and see. So most important topic is what is cloud computing. So the term was, I think, first reference in all the literature article in 1996 that way, but it kind of became very famous since 2006 or so. But yeah, before that, internet was depicted as a cloud symbol in so many uh, articles, etc. Whenever they wanted to represent a group of distributed networks. So a cloud symbol was a very basic mean to represent it, which simply masks the complexity of the network and infrastructure underlying it. And you won't believe it, the cloud computing now, it's all about that, masking the complexity so that developers like you and me can just focus on the application logic instead of worrying about the infrastructure or the backend thing around it. So it has come to full circle why the cloud symbol was used as a cloud symbol that time. Now, even though, like I said, I mean, it was first reference in 1996, it got popular since 2006, but it's not a very big deal to tell you. It's like cloud computing is a better evolved version of data centers itself. Like when I started working in corporate and started writing my programs, apart from what we used to write when we were having our labs, but the real world problems when we used to solve, that time all the web applications we used to create used to get hosted in data centers. But now cloud computing is so evolved, they are evolved version of data centers itself, but much evolved. I mean, we will come to that in subsequent slides and see why I'm saying this. But if you look at cloud computing broadly, now the spectrum revolves around these four things. One is infrastructure as a service, which is more or less all cloud providers. They provide entire data center like infrastructure where you can host your applications, databases, and all the things revolved around it. So they provide the infrastructure so that you don't have to have in-house network, in-house server capacity, etc. Next is software as a service. Say, for example, Salesforce.com. It's a good CRM tool in the sense you get to use the entire built-in software as is. So people who prefer using a software as is without any customization, rather companies with less technical capabilities or entrepreneurs with less technical background, they can use services like that. So Salesforce.com again is just an example to give you, so that the next point is very much clear. Next is platform as a service. Now Force.com is of Salesforce company itself, but then the difference between software as a service and a platform as a service is like in the platform as a service, the company provides you a platform to build what you want to create. So Salesforce.com has been created using Force.com itself. So it's like you get a lot of customization to play around with. So if you are a company or an entrepreneur who wants to get their hands dirty, they have a sufficiently talented pool of programmers or a development team, they can use platform as a service and build their desired tools over it. And one of the remaining thing is serverless computing, which is function as a service, or the other subcategory of it is container as a service. So we'll obviously get deeper into it as we proceed. Now, major cloud computing providers, right? So I've just listed few of them, but the list can go bigger than this. There are so many of them. So Amazon AWS is not the pioneer actually of cloud computing, but they put the cloud computing term to the foreground. They made it very famous. So in 2006 they launched their service, and this is 2020, and they have grown so much. They are one of the biggest. They have one of the biggest share in this market when it comes to cloud computing. The next one is Microsoft Azure, of course, and now it is very close fight between Amazon AWS and Azure. Amazon AWS got into this cloud computing world with a very simple thinking. They were creating their own infrastructure. You know how it's tough to get into Amazon with so many layers of interviews. So they have a pool of great talent. So they have built an ecosystem around this so that their infrastructure. So now that their services have also grown along with the infrastructure. But they started with this marketplace called Amazon.com, right? So in order to host that, they built so much of great infrastructure. They researched about a lot of tools. They implemented a lot of tools. So one fine day they decided, why not make money out of that as well? I mean, why not sell those kind of services so that other people can take benefit of what they have created and build their own scenarios and workflows over it. So that's how Amazon AWS came into picture. Microsoft Azure has been one hell of a backbone for development community, right? I mean, when we graduated, .NET was such a niche technology, and everybody was working on .NET. So that way, Microsoft has always been a technological backbone for all the entire development community. They have recently, it's been a while now, they have acquired a lot of other companies as well, which help and grow the development community. So that was their focus. With that mindset, they came out with Azure as a cloud service provider. The next immediate player in this cloud computing is Google Cloud, basically. Now, no offense, but Google always wants to be there everywhere. So that is why they entered this race, and their cloud system is pretty good. Out of this, I personally have worked on Amazon AWS a lot. Recently, I've started with Microsoft Azure as well. Google Cloud is little. I don't have hands-on experience on that. So, like I said in the beginning, Amazon AWS will be the thing. I'll be demonstrating this fundamentals about databases on cloud, but almost all the services, etc., are there on Azure, Google Cloud, and some other service providers. Now, after this, one of the major service providers is Alibaba, but of course, I think all these things going around about banning China and all, I thought I'll ban them from my presentation as well, so I have not mentioned them. So let's see what all options we have to host the applications in the cloud. So, like I said, let's talk from the point of view of web development for now. More or less, other type of development can be in cloud depending on the workflow. Some of embedded systems cannot, of course, be on cloud, but the backend services for those can be on cloud. But yeah, like I said, let's try and understand from the web development point of view. So if you look at it, there are many more options than this if you go at a granular level. But however, the first 3 points I have mentioned over here, which you can see on the screen, are more or less the most important top level categories. One thing, the first point is virtual machines. So at some point of time, you would have created some application, you would have hosted it If it's a Microsoft technology, you would have, or you're working with Windows servers, you would have hosted them on IIS. If you were working with relatively open source technologies, you would have hosted them on Apache if the server is Linux, for example, or and the technologies like PHP, etc. So that way, whether for your projects you have created all those applications on your own machine, or you have actually tried taking up server space somewhere, cloud or otherwise, and done it, hopefully you will have some experience with hosting web applications on the server. So virtual machines are exactly same way. I mean, even if it's a server in your lab or it's your own laptop, it's ultimately a machine you get access to without going further deep that what is oscillation, etc., which is out of scope for this topic. It's ultimately you're going to connect it to a machine remotely, and you can do whatever you want. So you can install a DBMS service, you can install IIS if it is not already installed, you can install Apache, and then go on with your hosting or application hosting, if web application hosting, if I can be specific. So Amazon has this service called AWS EC2, Elastic Compute Cloud. So that way you can within few minutes start a new server, load the things over it, and we'll get to it in in little details. But you can have pre-created servers also getting started for you, in the sense you are sure that I want a mean stack, MongoDB, Apache, etc. So what you can do is you can choose a server configuration such that all these services are pre-installed, and just you are ready to start with your application. So that's the beauty of cloud computing. Like I said, we'll get into detail in a while. Next, we spoke about serverless functions. So when we said serverless serverless function as a service or container as a service, of that function as a service is a way for you to host the application. You would have heard about REST APIs, that being a backend for the front-end application. So all those APIs, you don't necessarily need to have a server for it, so that you have to take care of the hosting, configuration, etc. It's not needed. AWS or similar service providers have services for function as a service. So you create one handler which will accept data. In the sense, if it's a REST API, you might be submitting some data, posting some data to it, right? So similarly, you get a URL for that function, you post the data to it, and in return, it will give a response. So, and that too, where you won't even have to know where the function code is residing. When you create the code, when you deploy the code, you just have to specify the language you are coding in. And trust me, there are various options. You can use Python, you can use Node.js, you can use .NET Core, and so on. Java is also there for all Java fans. So that's about serverless functions. Next is containers. I'll not talk about containers much. I've seen the schedule. You have one more session just dedicated for containers. So I think it will be great if I save your time. But just to brief you, containers are a bucket sort of, bucket in this context might be a wrong word. Container word itself is kind of self-explanatory. It's a container with bare minimum services running to it so that your code runs. I'll put it this way and stop for now. So you create containers and put your code into it ultimately. I have put this fourth point as a separate point with a specific reason. Static websites, if you have, then Amazon has a very beautiful service called Amazon S3 on which you can host your static websites. Virtual machine, ultimately it's a server. even though you don't have to manage much creating about it or managing about it. Serverless functions are there, containers are there, but for a very basic need for hosting a static website, you get a service called S3. You can point a proper legitimate domain to that. You put your HTML files to it, and that's it. I mean, you can run a proper website out of it, and it's very, very cheap. It's absolutely, not expensive at all. Now, when I'm saying static website, it need not be just HTML pages. Now, if you have some dynamic portion to it, you can still achieve it via REST APIs kind of scenario using AWS Lambda functions again. So it's not just about static HTML pages, but ultimately, if you have a front-end app, a web app, it can be put into S3, and the backend can be anything else then. That's about S3. We'll touch this topic again after a while, after a few slides. Now, moving on, what are the types of databases? Again, so these are not all the types of databases. Since we're talking from a web app development perspective, I have not touched about a lot of other type of databases which might be required and good for say data mining or data sciences, right? So again, so these are all top level categories under which everything can reside. Relational database, I don't want to talk about them in detail. You have learned about them enough. I'm sure in your syllabus there might be references of other topics, other types as well. But let me explain you some things about them. So apart from relational, there are three main categories of databases: key value pair databases, document databases, and in-memory databases. Now, like I said, there are some other databases like graph database, column value databases, etc. But more or less, they are similar to what we are going to see about in these three topics. So yeah, first is key value pair databases. Ultimately, the world in web development has started to move to a category where, a type of development where the most of the logic and calculations are not on the server. Server just gives you data so let's continue our example of REST API. So in that sense, the backend or the server takes some input and gives the result. So it is not busy computing a lot of stuff. All the logic can be transferred to JavaScript side or client side with all those new frameworks like Angular, React, and so many of them, Vue.js, etc. It's very easy to do things on client side, unless, of course, the logic is not. It doesn't have to be so secure that you don't want to code it on the client side so that it is revealed to the entire world. So not in such scenarios, you can definitely use non-relational databases of these kinds. So in such scenarios, what happens is, let's take an example of e-commerce website. When you go to a product page, there is a listing page, and you see a lot of options. You like something from the description or a photograph maybe, you click on it. Then what loads is called a product page. So it has all the information related to that product page. As such, there is nothing to hide in that, even if there is some logic, right? So key value pair, now you would have seen the URLs of such website. There is some identifier in the URL which uniquely identifies that product. So the key value is, in that key is nothing but that ID which uniquely represents that product, and the value is the entire information about that product in some format. So that entire thing can come as a data to client side, and the rendering or the UI loading can happen on the client side. Now, I am from a edtech background, so the other two examples I've given are from that domain. So, for example, in edtech, students take a lot of tests. So, when students submit the test, those test responses, in the sense, what is the answer given for each question by that student, that can be stored as a key value pair again. So, actual for loading the test, there are set of data like what question, what are the options, etc. Those can also be stored as key value pairs. Like, this is the test ID, give me the entire data for it. Now I'm submitting for the same test ID, and this is for this user ID combination becomes the key for that storage, and I'm submitting the data for it. So that's kind of key value pair at a broad level. Document DBs are similar to key value pairs, but they are more suitable for relatively structured data. Let's take example of CMSs, like blogs. So you would have read so many blogs about technical articles, etc. Right? So all those websites have very structured data. There will be a title, there will be a main article body, there will be a set of comments, there will be author. So this entire thing can be stored in, say, XML format, which is an older format, or a JSON format, which is relatively newer and getting famous with all those front-end frameworks we spoke about, Angular and React, etc. So because Angular and React ultimately work with JSON objects, and they accept the data in JSON and just renders them with the UI framework which is there built in that, and of course with our logic and UI, CSS, HTML, etc. So it takes that document and the logic which we have written for giving it a shape takes in, and the rendering happens, right? So if we had to use a relational database for that, the entire data, after reading from the relational database tables, we have to compress it in a format so that we can send it together in an XML like older days or JSON, and then the client will process it, or whatever the UI layer is, it will process. If we are using such frameworks which accept JSON directly, why don't we store the data as JSON directly? That's when the document DBs came into being. So we store the entire JSON as is, and that gets written. Blog website, etc. The most important use of these will be logs. For example, if we take example of IoT, Internet of Things, most of the devices sends back lot of data, which is, I mean, if you look at it, logs, games, and Internet of Things example are going to be little overlapping. So Internet of Things, if all the IoT enabled devices, they send a lot of data to server about the usage of that device. So all that data, or if you're playing a game, online multiplayer game, then constantly there is some data being streamed between the client and the server. If the application is maintaining logs, again, it's well structured kind of data which is being stored. So why to use a relational database service when we are going to need, what ultimately we are going to need is a document or an object directly. So just store that as is the idea behind document type of DBs. Next is in-memory database. In-memory database are not very new thing. For example, if some people who have worked with MS SQL or MySQL, all those servers for the relational databases, they ultimately put data into memory itself. I mean, most frequently used data in the memory so that the queries are faster. Uh, so in-memory databases take this idea to a next level, in the sense the entire database is into memory. I mean, I'm not saying that database is only in memory, but the entire copy of it is in memory as soon as it is working. Uh, I mean, you'll ask why it is so. Now, say there is a real-time analysis of data. So all that uh, uh, examples of games or IoT devices we spoke about, most of it is not processed immediately, especially if we talk about logs. They are, so for example, the basic use case of logs is later if something crashes, we can have a look at them and start debugging. So all this data is not exactly used real time. Whereas there are fields where say for example, data mining, etc., all those things have evolved to a stage where the analysis of the data is immediate. Say for example, a cricket match when it's happening, you see all those number crunching done, and you get to see a lot of statistics and all. So so that real-time data has to be analyzed fast, and to do so, the entire data, if it's in memory, which is RAM, then it's very fast. So apart from storing it on disk, like traditional relational data or any other databases, the entire data is also in the memory, so that it is faster to produce. Now, other example of this will be server-side caching. Now, if you want to store something, some data which is going to be very frequently used in your application, then fetching it from the database, which ultimately might be reading from disk, or say flat files on the disk. Instead of doing that, if we store that in the memory immediately. So these are the use cases for in-memory databases. Now, like I said, there are many more type of databases, but broadly they will ultimately get categorized into these four if you look at it. Now, the next 2 points are about how will you host your databases on the cloud. So broadly, there are two options. Install it with service. For example, you could take a copy of SQL Server setup or MySQL Server setup and start installing it on your laptop. Similarly, you can install it in your servers or virtual machines in cloud, or you can use hosted services. We'll get to them in detail in coming slides. Now, we spoke about so many types of databases. So how will you, first of all, decide which type of database is suitable for your use case, your application? And this step is required even before you think about where you will host it, right? So some of the key factors which determine this decision will be, one of them will be technology. So like I was referencing, if you are using Node.js and React.js kind of UI framework, obviously you will be you will be working with document type. It's better if you use document type databases or key value pair databases like we discussed. Now, other is nature of workflow. For example, if your project or application requires a lot of complex queries, if there are transactions, like if you're building a banking system, or any sort of transaction need not be financial or monetary, but where the atomicity of the ACID properties of data are very important, then in such cases you will choose relational database. I'm not saying non-relational is not suitable for it, but relational is better in that case. One of the other factor, most important of course, will be cost. So typically, we have observed that non-relational databases are more cost effective. They're less expensive, and you get to extract more with the smaller cost. With advancement of newer front-end technology, like we discussed, the Node.js at the backend and React.js framework for UI, like that. Uh, but yeah, I mean, is it you? Do you have to choose one always? Yes and no. I mean, if you look at it, so let's take example of Uber when they wanted to shift to a NoSQL database, non-relational database from relational database because the data was getting huge. They were, I believe, were on Postgre database before the relational database, and with so many rides being taken simultaneously, the data was getting huge, and relational was not a good choice because see, ultimately. The users are going to use the application from the mobile interface. I mean, the mobile application. Now, the data which travels between that mobile app and the server has to be light, and it has to be in a format which is very easy for the app to consume and process. So obviously that data was then traveling in some sort of JSON or similar structure, right? So again, non-relational was a no-brainer. They had to choose non-relational databases, but they did some research. They had a technical capability, and they chose to use MySQL as a key value pair database instead of going for traditional key value databases. So yeah, I mean, relational databases can be used as non-relational because ultimately, say for example, if you're going to use, if you're going to store key value anyway, so you can have a just 2-column table, the first column being the key and second column being the value, and you can have primary key on the key so that it is indexed and served faster. So that's what they chose. I'm not sure whether they have changed it now, but that's what the latest data. So this is one option. Most important is it doesn't have to be a radio button type of choice that you can only choose one. In some cases, it can be a checkbox type of situation where you can have both type of databases. Say for example, like I said, I am from a tech background. So when we create questions, we store them in relational database so that a lot of structured querying can be done around it. In the sense, a question was, pick a question of from this particular concept, which was not used in last 3 years, so that we don't serve the repeated content to our students, right? So such type of queries are better suited for relational databases. But ultimately, once we choose the questions and create a test out of it, in most of the scenarios, all the students who are going to appear for that test are going to see get the exact same structure of that test, right? The same set of questions, same question body, same options, etc. So when and then obviously we want our servers to be free to do much more than process this data and create a structured document around it so that it can go in one go. So we also want to have the entire processing outsourced to the client side. So the question doesn't come from server in the HTML format preloaded. Just the data comes on the client side. That's how most of the players in edtech are creating their applications as. That the data comes on the client side and rendering happens on the client side. So like we have discussed before, if it comes in a JSON format, it's very easy for the client side technologies to process and show that immediately. So if it has to be served in JSON format, like I was discussing when we were discussing the type of databases, why not, if they are going to be, the server has to serve them as JSON document, then why not serve them, why not store them as JSON itself on the server? So what we can do is, while creating a test, we can read the data from database once, convert it to a document or JSON, which is going to be used by the test player or the test engine, so that all the 1,000, 10,000 or 50,000 students taking the test at a time just get the data directly without any conversion from a relational SQL schema to a non-relational JSON database. So you can use something like that as well. Similarly, if we want to post the data back to the server, so when students submit the test or in between if you are submitting the test, what we can do is that data gets submitted anyway as some document, XML with older systems or JSON in the newer system like we discussed. So server request can just simply take that data and tell the student that in relation different tables, right? So instead of processing it at the processing, so many might be scheduled 1,000 students are taking that test, then so many processing units will be there simultaneously on your server. So why to keep the server busy? So we can store that JSON document which has been received from the client side as is, and the asynchronous process then can process it and put the pieces of that document into respective relational databases table. So mix of relational as well as non-relational is also a very good choice depending on your use case or workflow. Now, most important thing is, we spoke about all these database types, etc. and all, but my topic is about database on cloud. So now let's switch to that cloud part of it. Now that we have covered things like application hosting and databases and need for databases. So why cloud? Why store databases on cloud? So one obvious reason is obviously because the app might be in cloud, so it's easier for app to talk. I mean, when I'm saying app, the backend services majorly, they have to talk to the database for storing and querying data anyway. So the most important reason is, you have to store the database also in the cloud if the app is in the cloud. But otherwise also, if your app is not in the cloud, then also storing databases in the cloud is a very good choice for these reasons. So whether it is app hosting or database hosting in the cloud, the most important advantage of cloud is that it takes the load off of you. Now, when I'm saying load is, so whenever we used to code for a simple program, first thing we used to do was, and you are also doing, is install all those libraries on your laptop, right? And it's exciting once. It is not exciting if you have to do it so many times, day in, day out, right? I know there are guys who are aspiring to be database administrators or server administrators. For you, that might be fun, but for most of guys who are into application development will not prefer all that. So us developers or app developers will prefer creating new stuff rather than getting ourselves busy with a lot of installations, etc. So with cloud, you don't have to worry about it. The configuration part, installation part gets taken care of. There are automated scripts for it. So that's the configuration. Now, when we are studying as such, we might not be giving importance to licenses. There are paid products which you're supposed to buy, and you're not supposed to use it without a proper license. You have to read all those agreements, license agreements before installing the license. But most of the times what we do is we just check I agree and proceed. But if you continue doing that in your corporate or your office scenario, you might get into trouble if you end up not adhering to those licensing terms, right? So you have to go through and read all that. But again, not if you're using cloud. So you don't have to worry about the licensing. You pay for all those license fees. Obviously, in a sense, you have to take care of licenses when you are planning your resources, but then not in very deep. You don't have to buy them, etc. The fees these computing cloud computing providers charges is include. I mean, it includes the licensing part of the uses. Next is maintenance. Now, you all know that the software is. I mean, the compilers or libraries are not just about installing once. If there is a patch, you have to install it, you have to update it. All that maintenance is taken care of by the cloud provider. You don't have to worry about it. High availability is going to be very important. If your say application is 24/7 like Facebook or Gmail, etc., then that's their headache in a way, because the underlying infrastructure is their responsibility. So high availability of the infrastructure is their responsibility. Obviously, the availability of app is your responsibility as the developer. But as an infrastructure provider, they will be taking care of the high availability part. Scalability is not managed by the service providers, but it's very easy for us to manage and scale to cater to the increased demand of our application. So we'll study this point in next slide, scalability in detail. But otherwise, these are the most important reasons why you should be hosting your databases on cloud. So that you can concentrate on the next best app you want to build and not spend time on the mundane tasks like configurations and all. And of course, it saves time and ultimately hence money now that you are concentrating on your ideas. So this scalability point which I spoke about. So how do you scale for more load when it comes to database? So now that we spoke about apps, how to host apps in the cloud, let's also briefly see how can we load balance the apps. What are the basic options so that we can better understand the load balancing of a database. So we spoke about VMs for hosting the apps, right? So VMs, it's very easy if your web app is stateless, in the sense the coding is done such a way that it doesn't matter which server the user gets connected to. I think I'll give you an example for this to be more clear. You would have used sessions if you have created a website. So if sessions are stored in memory, then if I, as a user, get directed to next available server in a load balance environment, then my session which was created on the first server obviously will not be available on the second server. So in such cases, it will not work. So you'll have to plan your application such that it is supported by load balance environment. You don't have to have a state dependency on the server. I mean, it is attached to one particular server. So you'll have to think about all those scenarios. Again, so here I had assumed that you know what load balancing is, but just to give you a quick background, a server will always have its capacity limitations as to what kind of workload, how much workload it can handle. So your server will have, say, 6 GB RAM or 8-core CPU. Then it will be able to handle only so much of load. So what happens if there are more number of users than your server can handle? So that's when we load balance. In the sense, there are multiple servers, and the request gets distributed among those available servers. So that's the basic idea of load balancing. So again, coming back to that stateless funda. So if the state of the user in your application is attached to one server, the load balancing will not work, obviously, for the reasons I stated. So you'll have to plan your app accordingly, but this is one of the options. If you are using functions as a service or containers as a service for your backend, then obviously VMs are not coming into picture directly. You are not obviously working on the VMs. The code is going to be on some VM, of course, but the cloud provider is going to manage it for you. So you don't have to worry. But that is why service and container as a service are scalable. You have to configure and so we spoke about one very interesting use out of a service. So ultimately, it's just a where what they call as a bucket. You just deploy your files over there, and you can get your website running in like say 10-15 minutes also. So in order to load balance that, obviously it's a managed service, so cloud provider is supposed to manage the load. But in order to make it more reliable and available with a great speed, there is an option called as CDN. So Amazon itself provides this service called I'm sorry, I'm just not able to recall that on an immediate basis, but they have a CDN service using which you can cache those static files on various nodes on the internet. So that's the basic idea of CDN. You can look up about CDN technology separately, but you don't, the browser doesn't always fetches the HTML of the particular URL from server. That HTML gets cached on various nodes over the internet. That's a CDN. So this is one way to balance your load out, so that the server doesn't even get the request for all those files. So this is all about load balancing the application. Now let's get back to most important topic at hand. How will you load balance the database? So when we spoke about VMs being load balanced, I mentioned about having more than one server and application being copied on all the servers, and all the requests get distributed among these servers. That is not exactly an option for databases. So you cannot have the same copy of databases on multiple servers and your application talking to those databases copies on a distributed manner. Because obviously, if one request goes to one database and next goes to other database, the data might not be atomic, right? So in the sense, one query gets one insert query gets executed on one server and other gets executed on other. So that's obviously going to cause problems. So it's not very easy to load balance a database, but there are options using which you can make. Ultimately, why do we load balance anything? To make sure it is available and it can scale as per the load your application is facing at that point of time. So there are ways to achieve that without having to have two servers where IT is happening. So one way for it to achieve is vertical scaling. That's an obvious solution. Vertical scaling is like increase your RAM as and when the capacity is falling short, you keep adding RAM. If it's if your use case is memory intensive, or you increase your cores, CPU cores of as easy it may sound while talking. It's not easy in the production environment. You cannot increase the size of the server without stopping it, right? In case of load balance application servers also, because there are multiple servers going on, if you want to increase the capacity of any particular VM, you can have one VM running so that all the traffic is going to that VM, and then you shut down one VM, increase the capacity of that VM, uh, make it available for the load balancer so that the traffic get distributed, and you can repeat it for the second server, and so on if you have multiple, more than two servers also. But again, this is not easy when it comes to database. Database has to be available all the time, right? Otherwise the application will not work. So vertical scaling is not very easy. You might need downtime for it. Next, there is a concept of multi-availability zone and read replicas. These are two special cases we will see for high availability in the next slides. Okay, before read replicas, let's talk about multi-AZ. I think we already covered vertical scaling. I missed changing the slide. Uh, so just to give you a brief idea about vertical scaling, it's like buying a bigger house for growing family. Like I said, increase the RAM or increase the CPU if the load is not, I mean, the current server is not able to take the load. So what is to be scaled, it depends on that. If you're, like I said, if your application is memory intensive, you have to increase memory. If it is compute intensive, you increase the CPU cores, or you increase storage if it's going to be applications like, say, Twitter or Facebook, where more and more data is coming into the system and getting stored. So the main drawback of vertical scaling which we saw is like how much more do you need. You'll always have a limit. I mean, you can always you can buy a bigger house up to a certain capacity. You cannot keep buying 8 BHK house or 10 BHK houses, right? So that's about it. And with vertical scaling, most important drawback is you will have to predict when will you need more capacity. It's like family planning. You will have to plan when you will need one more bedroom for your kid, and that, trust me, that gets difficult. And I'm talking about the production environment, not family planning. And most important thing is at what cost. So unlike family planning, the production load is unpredictable in most of the use cases. You will not know what time, how many students or how many users are using your application, right? So if there are not many users who are using it, but still you have allocated a capacity for a very big load, it will come at a cost, and most of the infrastructure will be underutilized. That's the most problematic thing to cater to. So that's about vertical scaling. So main thing is whether your application application writes into database more than it reads, or vice versa. It also depends on that. So the next point we were talking about is read replica and multi-AZ. It depends on that. So before we get into read replicas, let's talk about multi-AZ. Now, what is AZ? AZ is availability zone. That's a concept across all the cloud computing providers, but the terminology is, the terms or names for it might be different. Amazon AWS call them availability zones. Now, Amazon, like I said, cloud computing is a evolved version of data center, right? And when I said evolved, it's because Amazon or any cloud provider will take care of the infrastructure for you, but ultimately it's a data center. So the data centers are scattered all over the world. Say in Asia, we have several of them already from Amazon and other cloud providers also. Now, within a data center, what if there is a power failure in the data center and the entire data center is out of reach? Then what happens to the production load that particular data center is hosting, right? So what these cloud computing service providers do is they create multiple data centers within that premise, and those are called availability zones. So say the data center is in Pune, Amazon's data center, say if it is in Pune, then within that facility there will be two separate data centers powered by different backups for everything, whether it is a network or power or anything. They will be separately taken care of so that if one goes down, the other is going on. But again, so if you keep your load into only one availability zone or a data center, as they call it, you are not protected. So you have to design your application such that your data is there on both. But if it's application, then say if it's a VM, then set of VMs rather, then you have to make sure some VMs are at least created in different availability zones so that if one VM goes down, the load balancer will take care of it automatically and the load starts going to the other VMs in the other availability zone. So you can same way do it for across regions also. For example, what if there is a big calamity in one particular area? Most probably both the availability zone or in some cases, for Amazon at least, there are more than two also in some places. So if all of them are affected, anyway, your application is offline. So for disaster recovery scenario, if you want to plan, then obviously you need to replicate across regions. For example, not just keep your data in Asia, India region, you also keep it, say, in Singapore or US. So if it depends on your user base also. If your user base is concentrated in India, you can choose the next immediate neighboring country. Neighboring in the sense, not it doesn't have to. We don't need to share the border, but like nearest country availability zone region we can choose. So all these facilities are easily available for application load balancing or application high availability. For databases, again, write is going to be a problem. You cannot have multiple copies if, rather you cannot have writes happening to multiple copies. It's not scalable. So it's complicated, and again, so the advantage of cloud is they take care of it. So you have to specify when you are installing a particular database that whether you want a multi-availability zone or not. If you enable it, the cloud service provider will take care of the replication. Now, how multi is, even before we get to read replicas, the most important thing is the database gets copied on the infrastructure of a different availability zone, in the sense different data center. But obviously the application, the web application I'm talking about, obviously is going to talk to one of them at a time, again because of the write problem. But then why create copies like this, right? So what the underlying infrastructure of the cloud provider will do is it will take the data and keep on syncing to the copy. In the sense, if there is an update to a record or new record has been inserted in a database table in case of relational databases, or new values getting added or updated for non-relational databases, the changes get copied and synced to the copy database. So in case something goes wrong with the main master copy, the cloud providers have automated this scenario such that the connection will start, the request will start going to the copy of the database. And then ultimately this is not the problematic copy of the database is not available. Once everything is fine, the data gets synced on the second copy, the first copy which has gone bad. And once they are in sync, again, one of it is actually chosen as the live database. Most probably it will be the second which will continue, and in case of failure on the second one, it will switch to the first one. And you can have 5 copies in case of Amazon that way. And like if you go about it, there are multiple ways to overcome that number also. Let's not get into that detail for now. So ultimately, multi-AZ, multi-availability zone scenario is for high availability. In the sense, if something happens in one data center, the cloud infrastructure will shift it to another availability zone if you have enabled that option while you're creating the database. Now let's check about read replicas. So how they're different from availability zones is that availability zone, like I said, only one is accessible at a time, even though there are copies. However, read replicas are very different in a sense. So we were discussing about this, right? Whether your application writes more or it reads more. So for example, every time a test is created for my application, tens of thousands of students will read that data and take the test. So for me, that one exam creation process, one write, is equivalent to 10,000 plus or 40,000 or 50,000 plus reads for that particular data. So if that is the case, then we can definitely have something called as read replica. This is not a concept from cloud computing. You would have had read replicas possible even in the on-premise databases. But again, what happens is the entire load of configuration, maintenance, all we discussed, that gets taken care by the cloud computing provider. So read replicas is nothing but there is a constant sync of your data on a different server, like in case of multi-AZ, multiple availability zone. But both these copies are available for your application to access the data. So your application can then, first of all, if you want to go for read replicas, obviously you will know what connection strings are, hopefully. So in your code, you have connections predefined to a database. So what you'll have to do is you'll have to have 2 set of connections, one for write, so that it only goes to the master database, the main database, master copy of it. The writes have to happen to one database, like we have discussed already. But read can have separate connections. So we obviously, while coding, we will know whether this is a read query or set of queries or write queries. So if there is a write involved, you use the first connection string, and for read, you use the second connection string. Now, you can either have your application logic create distribute the load among servers using proxies, etc. Or you can use, again, the best advantage, like I said, of the hosted services or cloud computing is they manage things for you. So you can use a service called Route 53 in AWS, which will distribute your data. So there will be only one endpoint for your database. So your code doesn't have to worry about how we will distribute the read queries to, among all the read replicas available. So Amazon Route 53 service will take care of it. You somehow, will not get into detail again. You can somehow specify that for this endpoint, these are the read replicas for my database, and then your read queries will be distributed depending on the load and configuration to different various read replicas. So this is is basically used for uh, disaster recovery, wherein your if your master copy gets unavailable for some reason, what you can do is you can promote one of the read replicas as the master copy, because the sync is almost real time. There is a very minuscule lag in terms of syncing. So you can immediately switch on, rather upgrade one of the read replicas to primary master copy again, and your application is up and running. And mainly because you can have read replicas across the region, like I said. So you can have one replica in Singapore, one in USA. So in case, say, because of cyclone or any other disaster or natural calamity, we can always have our application running from, rather out of some other region, other data center, which was not the case of availability zone. Multiple availability zone, like we said, it's mainly for within the areas, like within Pune. If Amazon has, say, 2 data centers, if one goes down, second will be taken care. Whereas read replicas can take care of your problems if the entire city is not available. I mean, entire region is not available. You can switch to different region. So these are more or less the points I wanted to take. What I'll do is now I'll switch to Amazon AWS management console. So when I kept on stressing on the fact that you can let the cloud compute provider, Amazon in this case, do the heavy lifting for you. Let's have a quick look what I meant by that. So I'll switch to my browser and log in into my AWS account. So this is how the management console looks. So in short, you create, host, use services at just click of buttons most of the times, and your click of your mouse and keyboard. Of course, for all the coding enthusiasts and automation experts, automation enthusiasts, you don't even have to do this button pressing all the time. You can write code. Amazon allows you to do that. You can write code so that all the operational tasks can also be automated and you don't have to do much. So just to give you a refresher sort of, we spoke about virtual machines, which are like servers ultimately. So we will see what virtual machine is. We will go to a service called Amazon RDS. So we discussed about installing your DBMS onto a VM versus hosted services, right? So RDS is the hosted service which Amazon provides for relational databases. So I think let's start with virtual machine. If we just click on launch virtual machine, I'll show you how easy it is to get to a server running. Like we had discussed, and that I will describe this one fundamental thing much later. So now is the time. So you can have pre-configured copies of the servers. It's like you get a Windows 10 CD and you install it, or you get a Linux CD and you install a server. So it's similar to that. So an image is created of a server with bare minimum pre-configured things. Say for example, I want to start a WordPress WordPress app installed on the server, and I want to start coding onto it so that the basic framework for my backend is ready. Then I just search WordPress, and AWS has created so many, 143 options, and of course people like you and me have created 725 options, which are different from 143. So what I'm saying is, within WordPress you might have a special use case saying I want these plugins to be already installed, so you don't have to even worry about it. So all those, somebody. So most of the times, what happens is our app idea might be unique. Hopefully, it will be unique, but the technology required for it, somebody would have already used it. So you can search through all the community images. Let's for now go to Amazon created ones. Or you can choose the pre-built AMIs. So for example, if I just choose say WordPress certified by Bitnami, what I'll do is I'll click on select against it, so that image will get picked up. What I need to choose is what kind of infrastructure I want. So all these types, you will be able to find description of it somewhere. T2 micro, say for example, it's a one. I don't have the values by hearted, but say T2 micro is one CPU, 1 GB RAM, and then it goes to 64 GB RAM and so many cores also. So you then have to choose between the choices you have. The next screen basically provides you an option. Say for example, T2 micro, like we said, right? One CPU, one memory, one GB memory. So you choose out of that. Now this is a very interesting thing. So you want to learn anything on AWS. Most of the services have something or the other which is eligible for free tier. So you can try it free for an entire year without paying any money. So for example, for this demo, I'll choose this T2 micro itself. It is eligible for free. So again, it depends. It depends on the kind of things you use. For example, Windows is not free. Linux being open source is obviously free. So just the server is going to be free, not the OS cost. So it depends on the OS cost also. So because I have chosen WordPress, it's going to be a Linux machine, and there will be small fees which will be charged for from Bitnami, because they have done all the hard work of creating this image for you. So there might be a charge. That was the previous screen was showing actually. So T2 micro, there is no charge for it anyway. So EC2, which is the virtual machine, there might be a charge of $0.012 per hour, so which is very cheap, and again it is eligible for free tier. So you specify, let's not get into all these details, you specify some network related things. Then you add storage. You just mention how much size of hard disk you want, whether you want a SSD or a magnetic drive. And then you click on this review and launch, and click on launch, and the server will be ready within, well under 2 minutes. And you can just you will get credentials to log into that server, and you can start deploying your application over there. It's that easy. No more talking and negotiating with your data center provider, commit for a very large duration so that you get cheaper rates, although that is still possible in AWS, but these are standard rates. You save if you commit for a larger period. So this is how you create VM instances. For apps, we had discussed one service which is function as a service. So that's basically called Lambda in AWS. So what you need to do over there is you just need to click on create function. You create it as a handler function in whatever technology you use. And when I'm saying handler, it basically is a function which accepts a data and ultimately returns some data. That kind of scenario. So you can choose the language which you have used for coding. There are so many of them available. And say I'll choose node for now and click on create a function. I'll name it as test. And within well under 2-3 minutes, depending on the net connectivity, your function gets created, and you just have to copy paste your code or upload your code if it involves multiple files, and that's it. Your function is ready. You get an endpoint for it. Endpoint in the sense you get a URL for it, which you can embed in your application code and front end or server side again, and then your code is ready, your backend is ready, hosted directly. So that's basically function as a service. The other way to install application we have spoken about is containers, right? So which in the next sessions somebody else is going to talk in very much detail. So I'll skip that. But Amazon has a service called ECS, Elastic Container Service, which lets you create containers. If you are a Docker or a Kubernetes fan, you can have those as well stored, rather used. So the CDN service, for which the I was not able to recall the name, is CloudFront. You can use files in S3, and CloudFront can cache that data across various nodes all over the internet. These are the options which we discussed. Coming to the most important things, RDS is the Amazon's relational database service. So like we created virtual machines with click of button, you can create databases with click of buttons. So for now there are no databases. I just click on create database. I choose which technology I want, or these are all possible options for relational database. Say I choose MySQL. Now my Amazon Aurora is a version of MySQL Amazon has created. It's much cheaper than MySQL instances, and they have optimized it in such a way that it's easier for them to manage, and that is why the cost is less. So we can choose Amazon Aurora or MySQL. We choose the version, so we can. They also provide they also provide option to choose the older versions. Whether the database is going to be regional or global, these are small things which you can look up later. Again, like we chose a VM size, we can choose the database compute and memory power also. So for example, it ranges from 2 CPUs, 16 GB RAM to 96 CPUs, 768 GB of RAM. So it depends if your load is such a, so high that you want a underlining server where your database is going to be hosted, have these many CPUs and memory allocated to you, then you can go that higher. This is the choice where you want multi-AZ development or not. So multi-AZ, just to summarize again, it creates the Amazon infrastructure will create copies of the server, and if the main one goes unavailable for whatever reason, the copy can then come into place and immediately it will be available. You don't have to even worry. You will not even you will get notified, of course, from Amazon, but you don't even have to worry about it. It will happen automatically because it's cloud computing. The other non-relational databases can be, say, document type of databases. They have service called Amazon Document DB. So you just have to specify the names and some other details. You can create databases in couple of clicks. If you are going for key value pair, then what they have is called DynamoDB. So all these, see, you can see this word managed NoSQL database. So all these are managed services. You don't have to install, you don't have to update the servers, you don't have to make sure they are available. All that is done by Amazon for you. So Amazon DynamoDB is key value pair database. Relational we have seen. In memory, if you want to see, this Elastic Cache is in memory database. So it's more of a key value pair database itself, but it's just that it will be faster to query. So these are some of the points I wanted to discuss about hosting databases on the cloud, which I've taken you through example of Amazon AWS. You can explore Google Cloud if you want. You can explore Azure. Most of them, in fact, all of them gives free tier services. So that you can learn all this, try out all this with very minimum expense. Uh, if you have a very good app idea you want to discuss, you want help, guidance, specifically from database point of view, you can contact me. We can always discuss, try out ideas, discuss which is more suitable, which kind of services are more suitable for you, how you can apply and plan your application with help of all these services. I hope this was useful to you. I went through a lot of topics. I touched upon a lot of aspects. You can go through internet articles in detail if you are interested in any of them. You can contact me for any of these things and keep learning. Use this time of lockdown especially to learn as many things as. Yeah, so in case you have any queries, you want to get in touch with me for any help, you can get in touch with me on these touch points, my mobile number and my email ID. It was very wonderful to speak about the knowledge I have shared with you guys. I hope it was helpful to you. Yeah, that's it. That's it from my end. Thank you, guys. Thank you, Vesit, for the opportunity, for providing this platform for me to get in touch with all these students. Thank you.
Thank you so much, Gaurav, for such a wonderful session on database services on cloud. I'm sure many students might have learned something new. For any queries you have, you can contact him on the email ID which is given in the description below. Thank you everyone for attending the session, and special thanks to Gaurav for his precious time. I hope everyone had a great learning experience. Please fill the feedback form for the certificates. The link is provided in the description. Now I'll be signing off. Have a good day ahead. Thank you.